Hi everyone. I am Angie Jones and I am a senior automation engineer at Twitter in San Francisco. I actually used to work here in Raleigh. How many people live here locally? Yay! So this is like homecoming for me. Good to see you all. Today I'm going to talk about the open trinity of automation architecture. I'm going to start off with this tweet. It says, any developer who can't or won't write automated tests for their own code is not a professional developer. They're a dinosaur. How many people agree with this? Great, not everybody. How many people disagree with this? No one wants to raise their hand. All right. So I'm kind of on a fence with it. I see the intent that he had with it. However, it's not that easy. It's not that cut and dry to just say if you're not doing this or you won't do it, that you're a dinosaur. Like it almost reads as if there's some ill intent to this. I think that test automation is a craft in and of itself, and it requires certain studying, certain skills, and not to say that our developers don't have that skill set. They do, of course. However, they're putting a lot of time and investment into their own craft of developing whatever it is that they're developing. And so there's an opportunity cost if we're going to ask them to do the test automation as well. How many developers do I have here? Great. How many of you, keep your hands up, put your hand down if you are not actively writing your test automation yourself? Okay, so quite a few. Great. Wonderful. All right. So what I want to do is give you my 3 go-tos for open source automation tools that I use when architecting a new automation solution. Okay? Not only that, I'm going to give you the design and architecture ideas that go along with using those tools. Sound good? All right. So I'm going to go through 3 of them. One for UI, one for web services, and then also one for BDD. So I think we all can agree that clean code and developing clean code is a great practice. However, we have to really look at what does that mean. Just writing clean code isn't always about the syntax of the code, but also following the design principles and knowing these different patterns and things to use, right? And so I think that's where the gap is when we're asking our developers to craft these automation frameworks. So I've worked with a lot of development teams, and some of them have definitely wanted to do this and take this burden on. However, 100% of the time, this has failed with the development team. And it wasn't because they weren't good coders, they were excellent coders. Some of them were architects. They've been doing this for years and years. However, like I said, there was this gap here that was missing. And it was studying the craft and understanding the concepts behind it. I see a lot of developers who, they write beautiful code when they're doing so for the production app. However, when writing the test code, kind of just slap it together and get it over with. Just like your production code, your test code needs to have that same quality level, or else it'll crumble. Okay? So let's talk about the tools. When picking these out, there are lots of automation tools available. Lots of them. New ones coming up every day. Some of them are even promising you the moon and the stars with little effort at all. And so it's difficult to look through all of that and figure out what's best for my team and my environment. Okay? So what I want to do, again, is give you my 3, the Trinity, I call it, that works in pretty much any situation. Starting with the UI. So Selenium-Webdriver, this is the go-to, the king of UI automation. This is very much so industry standard. Pretty much any shop you're going to that are doing UI automation are using Selenium-Webdriver. All of these tools are open source as well. Selenium-Webdriver is not a testing tool, contrary to popular belief. It is a browser automation tool. So what this tool does is it interacts with the UI. It can set data and interact with the different elements on the UI, also read data and report that back to the code base. However, it's not a testing tool because it doesn't do any assertions. There's no pass or fail with Selenium. It simply provides the data, right? Now, any other tools that are out there, pretty much, I would say about 90–95% of the other automation tools, UI ones, are wrappers around Selenium. So there are ones for mobile, for AngularJS, for Node.js, if you don't want to use vanilla Selenium. I personally always just use Selenium as is, unless I'm doing mobile, of course. But the other ones, they will add a little things like the promise manager and things like that that make automation a little bit easier, but these are not required. But there are some of them, and they're all open source as well. Now let's talk about the framework organization and using these tools. Now, this is a Maven project, and you know Maven comes with two source packages already, the source main Java and the source test Java. It's really critical to divide your automation framework into these two sections, with the bottom one being the portion where your tests are written. This is where your test code goes. And the upper one is where your framework goes. Now, framework is anything that has to deal with the application, any type of helper, utilities, widgets, things like this. Your test code should read very much so like user interacting with the application, right? So let's say that we wanted to update a cart on an e-commerce site. Your test should read like, update this cart to quantity 3, verify that the total is XYZ, right? The details, the implementation details about how you go about doing that, that's the part that's extracted out into the framework portion. The reason you want to do this, you want to separate the intentions to make your framework not only clean, but also reusable and maintainable, right? So if you put all of that implementation details in the test itself, then when you need to do some of these same actions again for another test, you're finding yourself copying and pasting, and we know that that's a no-no, right? So this is a much cleaner approach, much more effective. Let's look at this sample page of an application. It's a cart, and it has one product here. And let's look at our scenario again where we want to update the quantity of this. Now, the way we would do this in the framework portion is we need to use what's called the page object model design pattern. So this is also an industry standard, and it works very nicely with Selenium tool. What you do here is for every page in your application, you develop a class within your framework to correspond with that page. And in that page, there are two sections. Think of pretty much encapsulation, where you will have the elements. This will be your class fields. These elements are the things on the page that you need to interact with, such as the button and the text field, any labels. And then the next portion would be the methods that you call to actually do those actions. So looking at this, sorry it's so small. Looking at this, these are the elements of the page. So here I have the cart table, the product price, quantity, different things like this. Now, in order to get these elements with Selenium, you have to get into the DOM of the page and give Selenium some way to identify that element. This can be done via ID, via class name, some type of attribute on the element. It's really important to be pretty skilled at this as well. So you want to be able to craft this in a way that you are getting a unique identifier, right? And so sometimes you need to use XPath and CSS selectors as well if those IDs are not available. Also, in modern day applications where we have dynamic DOMs, this stuff changes, and so IDs are not always adequate enough to get what we want. Sometimes we need to couple that with the state of the element as well. And so that's where your XPath and your CSS selectors come in handy. And then these are the methods that go with that. So setting the quantity. You use the WebDriver API to then say, find this element on the page and then do something with it. Maybe click it if it's a button. If it's a field, set the text. If it's a label that you want to read, then you get the text, things like this. So it's a pretty straightforward API, really easy to use. Now, how many people here are familiar with Mike Cohn's automation pyramid? Okay, not very many, so I'll explain it right quick. This pyramid is a representation of how your automated tests should be broken up and what layer you should be automating at, okay? Notice the bottom portion of this pyramid is the unit layer. What Mike Cohn is suggesting is that the bulk of your automated tests should be done at the unit test layer. The next largest portion is the services layer. And so what that means is if it's not a unit test, but you can automate at the web services or the business logic layer, then that would be great as well. And then the very smallest portion of this pyramid is the UI, meaning you shouldn't have very many tests at this layer at all. In practice, we don't really do this, although most of us would agree that this is a nice model to follow, because at the unit test layer, things are fast. You don't have to deal with a lot of integration and launching UIs and things like that. Services also much faster. The UI is slow. It's also brittle. This is where most of our failures come from, the flaky ones, the false failures. And so we encourage people not to do the most here. However, in practice, when you're developing a new UI feature, then it's really intuitive to want to test that at the UI. You want to make sure that that thing works. So how do we get around this? Well, most people, they simply violate this model and then they just automate at the UI. What I do is I say, I'm not going to restrict myself to any one layer of this pyramid. I can have a test that spans multiple layers of this pyramid. For example, let's look at our cart test again. Our cart test says if we wanted to update the quantity, we would need to launch the UI, right? We would need to search for the product. We would need to look through those search results to find the product they were actually looking for. We would need to click on that product. We would need to then click to add that product to the cart. Then we would go to the cart. Once we're at the cart, then we can go ahead with what we actually wanted to test at the UI, which is updating the quantity and verifying the price. That's a lot that's going on at the UI that isn't necessarily required to do so. So instead, what I do is I cheat. Let me use one of these other layers, maybe the services layer, to add the product to the cart via web service call. And then I can launch the UI and go straight to the cart and do what I need to do at the cart. So this gives me a couple of things. One, it speeds up my tests substantially, much faster than doing all of that stuff at the UI. Two, it decouples it from other parts of the application. Let's say, for example, that the search feature was broken. If search was broken and I coded this whole thing using the UI, now my cart test is blocked because search is broken. right? That's not what we want. I don't want to not be able to test cart because search is broken. So instead, I can use the API just to add it to the cart. I bypass all of these other things, and only the search test will fail, right? So to use the web services, my second go-to product is the Rest Assured library. This one is a DSL, and it is for Java. And if anybody in here has used Java to do web services, you know that there's a lot of boilerplate code that goes into that before you can actually get into making the call. This extracts all of that away from you. And so with one line of code, you pretty much can be up and running making a get or post call. Very helpful. All right, so for services, let's see where that goes in our framework design. I put the services in the framework piece, right? Not part of the test. Again, so that I can promote reusability. And in there, I would have however many classes I need and kind of parameterize these calls so that my test code can call into these very easily. This is a line in this is cart test. And in the test, I'm making a call to the cart. So what I'm doing here is I am making a product variable called Apple TV. And then I use the cart services class to say add this product to the cart. And then I go into my UI piece. So you see I've basically taken all of that UI prereq work and put that right into a nice web service call. Then I go to the cart page, click on it, and then update the quantity. And now I'm at my verification. So nice and short test. And this is the cart services class where I actually build up that web service call. So I get the product ID that I might need for this web service call, the parameters I can put inside of a map, and then on line 21 is the actual get call. So it says, given these query parameters and this base URI, make a get call here. So very simple, easy to use. You can use it straight out of the box. You add this as a dependency in your POM file, and you are up and running. So a lot of managers struggle with trying to determine whose job is test automation. It's very much so a software development activity, yet you need a quality mindset to really be able to tackle this properly. A lot of teams and companies are going with having a specialized person such as myself, a SDED or automation engineer, who essentially has the development skill set but also the quality mindset. I do recommend this approach. However, other people can still be involved as well, right? We still want our developers involved, creating the tests at their unit layer, or contributing to the UI tests if we need them, or the services tests if we need them, right? Also, we want them to be skilled enough that if something breaks, they can go in, they can update these tests properly. Our testers, who might not necessarily have the skill set of a developer, we still want them to be able to contribute to this effort as well. So one approach to doing that is by utilizing BDD initiatives that you already have going. Now, the BDD purists would kill me if I said that we should use BDD strictly for automation. So I'm not saying that. Let's just go on record. But what I am saying is if you're already doing BDD, and let me explain briefly what BDD is behavior-driven development, where teams use this approach to figure out what are the scenarios that we would go after? What would a customer actually do? And this is part of the design phase of the feature. And what this helps to do is to flush out all of the details very early in the process so that you can identify any assumptions or anything that you might not have thought of before. This is typically done by what they call the 3 amigos, which consists of product, development, and QA. All right? Now, in this process, what they do is use the Gherkin format to write out these scenarios. And the Gherkin format has a syntax of given, when, then. Given this syntax and these scenarios written in this format, you can then take this and it becomes an executable test case that you now can run as part of your automation suite. Now, what managers typically miss is this is not magic, right? So it's not you just write this out and now it runs. There definitely has to be some code behind this, right? And so there's a new layer that you need to add to your automation framework to essentially glue those scenarios to your code. So a nice tool that'll help us do this is my last open source tool, Cucumber. Cucumber supports quite a few languages, Ruby, Java, Groovy, JavaScript, Clojure, blah, blah, blah. So all of the languages, the great languages are supported here. And what I do is add this portion to the test layer, right? There's essentially 3 sections that I add for Cucumber. One is the Cucumber package by itself. This is basically the file that will execute all of these Cucumber tests. So this is where I put all of my options and things like that. The features is the files where the scenarios live. So you write these features inside of a feature file. That's the extension .feature. And you essentially write those scenarios in the Gherkin format. And then finally, the step definitions, that's your glue. That's what's going to tie those human-readable scenarios to your actual framework. Okay? So this is an example of a cart feature file. It says, the scenario says, we want to increase the quantity. Given product Apple TV is in the cart, when I update its quantity to 3, then its price should be $80 and its total should be $240. Very simple. People who don't have the programming background can easily write this and contribute that way. And then you would have your developers or your SDETs to then map that back into the code base. So the way you do that is for every line here in my scenario, it needs to be associated with some method inside of my code base. So before each of these methods, I have some annotation, which would be either given, when, or then. And then I use regular expression to write that statement out. Now, the regular expression you can parameterize, use wildcards or anything like that if you want to make these reusable, which I do encourage. If you use a wildcard, then you're going to also need to use a variable to map with that wildcard in your method signature. All right? Inside of those methods, that's where your magic occurs, or the real work. That's where you're going to say, okay, if you said that you want to do this, for example, if you said that you wanted to, that given statement, product Apple TV is in the cart, you didn't specify how that's done. That's done in the method itself. That's where you say, okay, well, let me call the web service call and actually put that in the cart, all right? You can do your verification and everything right here in these step definitions. Okay? Now, we're all about clean code, right? And so I've seen some teams who deal with this. Cucumber. Cucumber has this scope issue that's kind of good and bad. It's a bittersweet type of thing. And the way this works is all of the step definitions, no matter which file they're in, as long as they're in one of these step definition files and you've said this is the package that holds my step definition files, all of those are global. So you can use them across multiple feature files, and that's very handy, especially when you're doing some integration tests. What's not global is the variables and stuff that you define within these steps. For example, if I said this product Apple TV is in the cart, on the very next line, which is associated with another method, that method knows nothing about this product that I just talked about, right? So the scope of those variables are local to the methods. So what you need to do to get around this is to define those at class level, right? And then you can reuse them across the methods. Now, most people don't want to go through all that trouble, so what they do is kind of dump everything inside of one feature file. It's not good. I've seen it. It's not pretty. It gets very long, very cumbersome, very hard to maintain and manage. So instead, go ahead and define these out into separate files based on the functional area. And then what you can do is to use things like dependency injection to be able to make these work. So here I have another scenario where I am using, this is the search feature, and in this one it says, given there's a product named Apple TV, when I search for the product and I add the product to the cart, then the product should be in the cart. Now those first 3 lines of this scenario are very much so related to the search feature. However, that last one is something that would also appear in like a cart step definition file. But it's okay because those have a global scope and I can utilize them here in this feature file as well. Any feature file I want to, Cucumber will be able to find it, right? But what I need to do is I can use dependency injection if I want to use any of those variables and states and things like that across these files. So what I do is I create one base or a common step definition file. Anything that would be common across multiple of these step definition files, instead of copying and pasting, we definitely don't want to do that. I put them here in this base class. And then I can use dependency injection, and there are several dependency injection open source tools as well. Pico container, Spring, whatever you're already using is fine. And essentially, the way you connect this is by adding a constructor to whatever class you want to inject into. And inside of that, you would just go ahead and put that base step def as one of the arguments. Okay? Given that, now I have a handle, which is step data, and I use step data throughout to get to any of the variables or the methods that are in that comment file. All right? So that is my Trinity of open source tools. Again, Selenium for UI, Rest Assured for web services, and Cucumber for BDD. You can see that they can all work together very nicely. And I've shared some of the techniques on how to use that, how to architect that as well. All right? Any questions? Cool. So I'll be around for a little while. You can come and ask me anything. Also, here's my contact information. So I blog about automation techniques and strategies at angiejones.tech. If automation is part of your job, then I do recommend that you go ahead and subscribe to that. I'm also on Twitter, of course, at TechGirl1908. If you want to give me a shout out, my manager likes that kind of thing. So that would be great as well. Thank you. Oh, question. Yes, sir. Oh, good question. So he's saying that framework looked like it was in a separate repo. Would I recommend having it in a separate repo? It's not a separate repo from the test, but it could be its own repo altogether. Would I recommend that or having it with the development, the production code? Either or is fine. There's some advantages to having it in the production code base so you can utilize things. For example, right now I'm working on a project where I actually put it in the repo code. Here are some of the things that I gained because of that. Developers are much more likely to help with this stuff because they see it right there and they don't have to go to another repo to do this. Also, I'm able to utilize some of the identifiers that they've used, such as the accessibility identifiers that are defined in like its own separate file. I can easily use those to get my elements that I need for Selenium, as opposed to me identifying them myself and risking them being out of sync at some point. So there are some advantages, but I've worked for a very long time where it was a separate repo, and that's worked fine as well. All right, any other questions? Yes. Yeah, Great question. So he says, what about the commit? Are you running these on every commit? Are you running it as a secondary process? So it depends. Some of the tests I do run as part of every commit, so I identify which test would be a part of that strategy. If this is going to be a part of continuous integration, obviously we want fast feedback for continuous integration, and so running thousands of tests on every commit is not necessarily the best idea ever. And so the ones that are important, maybe pertaining to the features that we're developing, we can use like JUnit and TestNG. They have these attributes, these annotations that you can put on the test to maybe specify things like the functional area and things like that. So I can say, okay, if these are the areas that we're touching right now as part of development, these are the ones I want run as part of every commit. Everything else I can run later, maybe twice a day on its own, and it's not gating the check-ins. All right, any other questions? Yes?
So in your example where you kind of like went between the layers of using the web service instead of using and then testing with the UI, how do you handle when the web service changes? Maybe your testing breaks because of something that doesn't happen with the web service.
So he says, how do I handle maybe the fragility of the web service call? If something changes on the web service, then that can break my test. Same is true for the UI stuff. That's just the nature of the beast with automation. So we are automating against the state of the application as it is today. That target is always moving. And so our automation framework has to be updated constantly. And that's a key point that a lot of people miss. They don't realize that there's this maintenance cost to doing test automation. And so no matter if I'm going to use web service or UI, that's really irrelevant. Web services, however, at least should be a much simpler change, right? And so if they've just changed one of the parameters or something like that, that's fairly easy to change, whereas if we've changed the whole UI or changed the flow of a scenario, that's much more difficult to update. Okay, any other questions? Yes?
So if you have multiple branches in development and a feature is not going to go out for 2 months, then how do we choose which test to run for branches that are not necessarily going out this month?
So I've seen people who will also branch their automation framework to go with the development branches. And so we have this branch that goes with that. If we're going to work on another branch that's totally different, then we branch our automation code as well. Keep it in sync with the production code. All right? Anyone else? Wonderful. Thank you all so much.